I hope you're all doing great. I am Mr. Ish. Thank you for joining me. When you're looking here at reactions between strong acid and strong base, HCl and sodium hydroxide, you're really not looking at a titration because that's between something strong and weak. These are more of neutralization type of reactions. That's what they really are. And there's no need when you're doing the pH calculations for these type of scenarios to even come up with a equation. You know the end result is always a salt and water. But let's look at two examples over here where a strong acid and strong base react and we have to find the pH. The first one is 1 molar HCl 100 milliliters reacting with 0.8 molars 40 ml sodium hydroxide. When you're solving these type of questions, you always want to do comparison between the mole strong acid and the mole strong base because that will determine what the pH will be. Either the pH will be very acidic or it will be very basic. And you know molarity is equal to moles times volume, so moles is equal to mV. Convert everything to liters. We have 1 molar 100 ml, that would be 1 times 0.1. Here we have 0.8 molars and then 0.04 liters, which is 40 ml. Which one would be more? You'd have to compute it. 1 times 0.1, you know that's a 0.1. 0.8 times 0.04 is a 0.032. You know this right here is in excess. The acid is more. Any amount of this will be fully used up to neutralize to the greatest extent your acid. What will remain? You'll do 0.1 here. 0.1 moles of acid minus all the moles of the base you see. 0.1 minus 0.032, you're going to have here 0.068 moles acid. But to get the pH, you have to convert this into concentration. Divide this by the total volume. What's the total volume? 100 plus 40, which is 140 milliliters or 0.14. And you'll get your molarity here, 0.068 divided by 0.14. We'll have here 0.4857 molars H plus. And you know pH is equal to negative log of that hydrogen ion concentration, which is exactly what we'll do. I'm going to take the log of it and I'm going to minus it, negate it. I'm getting here a pH of 0.3136 and that'll be the answer. In a system of 1 molar HCl and 100 milliliters of strong acid reacting with 0.8 molars 40 ml of sodium hydroxide, because the strong acid is in very much excess, it will determine the pH and it's going to be very acidic, very close to zero. But you can see the entire base is used to neutralize to the greatest extent the strong acid. The remaining amount of strong acid will determine the pH. Question number B. 1 molar HCl 100 milliliters. Do the moles of H plus. We know it's again 1 molar times 0.1 liters is 0.1. But look right here. Moles OH is going to be what? We have 0.7 molars and 200 milliliters, which is 0.7 times 0.2. And you know this is going to be 0.14 moles base. Which one is in excess? This is in excess. So now this will be used up. The acid will be used up to the greatest extent to neutralize as much as possible the base. 0.14 moles OH minus 0.1, which is the full amount of the acid. What will you have? You have 0.04 moles strong base, which you're going to divide now by the total volume. 100 plus 200 is 300, which is 0.3 liters, and that'll give you the concentration of base. 0.04 divided by 0.3 is 0.13333, repeating hydroxide ion concentration. You're going to do the POH calculation. POH is equal to negative log OH minus, and run this through. 0.133 log, it's a 0.875, but pH plus POH is equal to 14. Therefore, pH is equal to 14 minus this. What will we get? 13.12. That will be the pH of this system here, which will be extremely basic. You have now more strong base, less strong acid. Therefore, this will drive the entire pH calculation and make it a very basic solution. But in all cases such as these, strong acid, strong base, it's always a neutralization reaction, not truly a titration. Thank you for watching.